So we're going to have a look at Wireshark and capturing traffic while we're scanning using our scanning tools. So we left off with Wireshark running, so we'll run that up again. And we'll capture on our Ethernet interface, which is a 129 this time, so it's slightly different. And just to test if that's capturing, we'll check our routing table for our default gateway, and we'll just send a couple of ping packets, so -C for count. So I'm going to send a couple of ping packets to our default gateway, which is at, so it's going to go through 129 and it's going to go to 7134, hopefully. So that's the 2 packets and it stops. And we can see our packets. So if we pull down, make our window a bit more sensible. So if you haven't used Wireshark before, there are lots of tutorials around. We have quite a large tutorial you can go and play with. If you haven't used Wireshark, maybe just mention that in the forums and I can post that somewhere. So you can see our ping, ICMP ping packets here. So we've got our protocol. So these are all your packets here, and then this is each packet which you highlight. It gives you the details here, and then this is your raw window, which is what we talked about in the lecture. So you've got your hex here and your ASCII conversion from the hex there for each packet content. So these are the headers. So we've got our layer 2, our layer 3 header, which you can open up and have a look at the details, and we've got our ICMP header sitting here. So we've got a type 0, which is a reply, and if we highlight one that's going out, so from 129, which is our local IP address, out to the gateway. So this is a request going out, and that's one of the replies coming back that we looked at. So our request should be a type 8. There you go. So I've got type 8 there. So we've got various things in the lab which we're looking for. So we're looking for the length of the ping packet and the ICMP type. So the length should be, you should be able to pick the length up from here. The lengths of each individual header will be in each header, and the length of the entire frame should be around here somewhere. And the other thing was the code. So if we want a ping request going out, we've already kind of given that one away with the type here. So you've got type and code. So yeah, by default this doesn't seem to show our filter. So yeah, so if we go in and show our filter toolbar, that's not very great, is it? So show our filter toolbar. So this is a display filter. So it's giving you some details there. That's good. So our display filters can basically help us filter out the interesting traffic in the display here. So the filters we're talking about for tcpdump in the lecture are actually the capture filters. So they're filtering out the data as it's coming through the interface itself. So we also have capture filters in Wireshark, which you can actually go in and set up here. So you can actually set up exactly the same filters as tcpdump in this window, which will mean you're only going to see, you're only going to capture and see the data you want, the packets you want. But what we can do is while we're capturing, we can just use this display filter. So it's slightly different terminology, different syntax, but there's some really useful filters you should really sort of know off by heart. So you can actually build up an expression by clicking this, and you can go in and say, well, the stuff I'm interested in is IP. So you can find the IP protocol, and you can then, if I can find it, so IP version 4 I'm looking for. This is there we go. So if we go into IP version 4, and we can use any of these things, so we can say IP address equals, and then we give it a value. So for example in the lab, I think it's a specific machine, so there you are. So it's 10.200.0.1. So we can say we're only interested in packets going to going or coming from 10.0.200.1. Is that right? 10.0. Yeah, 10.200.0.1. Okay, and it pops that in here. So you can type that in. So that's going to give us, if we apply that, it's going to give us nothing because we haven't actually sent any packets to that yet. So if we just maybe send a couple of packets to that. Oops. We give it a parameter. Send 2 packets to that. We should see the packet. So it's only showing traffic going and coming from there. So you can actually say source or destination address, but this gives you both. So quite a good thing to do is to possibly just find a Wireshark cheat sheet. So I know there is actually a good one. So display filters. So if we find that, you can go to the Wireshark documentation itself. But actually, there's a really good cheat sheet which just summarizes everything. So I quite like. Yeah, I think it's this packet life one that I use generally. So this is quite good. So it's got all sorts of things you can use. So these are capture filters, and is that the wrong one? There's display filters. Oh, no, that's back to the Wireshark documentation. Apologies. There we go. So it's those 2 pages there, 3 pages. So that's the display filter. So you got so your Ethernet layer, your ARP packets, TCP, and IP. So that was the one we used there, just to filter out certain hosts by address. So that's quite a good thing to maybe. It's actually printed and it's on the wall in front of me. Would you believe? So yeah, that's a good thing to use. So we can use Wireshark, and as we mentioned in the lecture, this is good for packet analysis and capturing packets and monitoring your traffic. But what we're also interested in using was a more text-based simple mechanism on the command line. So what we can use is tcpdump. So what's good is to actually make your window, I think this thing, there we go, to make it fairly wide so you can get as much information. 1 packet per line is quite good. So if we have a look at the help, so all these tools we're going to use, if you have a look at the help first before you use them, the man page is good too. So we've got tcpdump, which runs on top of libpcap, similar to WinDump, which runs on top of WinPcap. So you might have seen WinPcap in your eSecurity with various tools such as Wireshark and Snort running on top. I think maybe done a little bit of C# programming on top as well. So you've got lots of different options. So if we have so we've got the slides up. So I suggest you use the slides from the lecture as a reference for a lot of these practicals. So these are the PDF slides from the lecture. So this is the tcpdump section, and these are the useful, some of the useful flags and parameters we've given you. So -d, display network interfaces. So let's give that a go. Let's see what we have to play with. Oh, Let's give it the proper command, might help. Okay, so that's our interfaces. So we can specify these by either the name or by the number. So that should match our interfaces we have. So -i to specify the interface, -n, we're always going to use -n, so we don't do DNS lookups and such like, and port number resolution. Verbose is good to use most of the time, and then these options are going to give us various different outputs, different depth of outputs. So let's just check if it's working. So we can give it either -i1 or we can give it our ETH0, and let's just do no lookups and let's give some verbose output. Okay, so similar to what we did with Wireshark, that's now listening. Again, we just send a couple of packets out to our machine that we're looking at. You can see the headers are being printed out here. And we've got some other stuff. So we can see our packets start here. So they start indented on the left hand side, and this is the same packet. Okay, so you're getting all your details here of the IP header. Your protocol is ICMP, and you're getting the length, and you're getting the IP ID here. This is then the ICMP details. So this is your length of your ICMP part, and that's your ICMP ID. And we're seeing it's an echo request, and here's our IP addresses, so our local interface, and going out to the machine we're sending the packets out to. So if we stop that and run it again with let's use -x, so that should hopefully give us our hex and ASCII, very similar to the bottom pane in Wireshark. And again, if we just generate a couple of packets to have a look at, so we're going to get a couple of packets going out, and we'll just stop that with Control-C till we have a little look. I'll analyze what we got. So we've got a couple of packets going out, and we should have a couple of packets coming back. So there's our packet going out, and that's our reply packet coming back from the target. Okay, so it's specifying our reply, and again we've got our ID for our ICMP part, and we've got our ID for the entire IP. So this is our ASCII, and this is our hex of the content of the packet. So what we're asking you in the lab to do is to use this command. So have a couple of terminal windows like we've been doing there. I think we're doing a ping sweep rather than a pink sweep. And to use tcpdump with some of the flags, so you can kind of put all the flags together here. So we've got -v, -n, and -i, and then this is the value for the -i parameter, and then we're actually using a filter, and in this case we're redirecting the output away from the screen into this dump file, which is in /root/dump1. So if we have a look at the so these are some of the examples we did. So these are the tcpdump filters, or some of the common ones. So we've got our protocols. So if we wanted to look for example, UDP packets, we could say tcpdump -n v -i interface, and then we could have UDP at the end. If we wanted to only look for packets from an address, we could say source. You can use source host, or you can just use source IP address. Or if we're looking for destination packets we're sending somewhere, sending to a particular target, we could say dest and the IP address at the end. And we could also combine things. So I think in the lab it asks you to negate some things. So it says don't show our SSH traffic, for example. So we can say not SSH at the end, and we can also join things together. So we could say something like, if we wanted to look for web traffic, we could say at the end of our tcpdump command, we could add the filters TCP and port 80 or a port range and an IP address, or sorry, and host IP address, or and source or destination IP address. So we could combine all those things together. So we could do something like, so let's take that off so we just see the headers, and we could do a filter which said something like host, or let's do say not SSH and host oops, that's not going to work. So we can get, let's just try that. So we get, so let's try our ping again so we can see that that's working. Okay, so why did that previous one? I think you need to use port. So SSH is just for 22. So I think that should work. There we go. So it's saying not port 22 and only towards the host. So it means we wouldn't see any of our SSH traffic for generating any of that is. So it's still working. Excellent. So if we wanted to, we could specify something like, let's just get back, we could do something like and port 80 and not port telnet, so it's going to give us no telnet traffic and only port 80 traffic. Probably don't need that, and not telnet, and to our host. Oh, that's excellent. Oh yeah. So we don't have an and here, so the first filter is port 80. There we go. So we'll just be looking for, so this shouldn't capture our pings this time because we're only looking for web traffic. Ace. Good. So let's have a look at what the lab's asking. Let's try one of these. So it's asking us to capture traffic on a Ethernet interface, and it's asking us to capture only ICMP traffic using this filter, and to redirect it to /root dump1. So let's try that. So instead of our port 80 filter, we want ICMP only, and we wanted to redirect /root directory and the dump1 file. Okay, so that's now going to save it off to here. If we just try our ping just as a test to see if that works. And we've got our dump1 file. So we're in /root, and this is our dump1 file that we've created. So if we just, there's nothing in it. Excellent. Okay, yep, so if we stop our capture, we can actually get at the file. Yeah, so there's actually something in it now. Okay, so we've got packets in there. So let's start our capture again. Let's see what we want to do in the lab. So we want a little for loop. So he's looking to go from 1 to 30 and use that variable here. So we're going to ping across all those addresses. So 10, 200, 0, 1 across 10, 200, 0, 30. So if we want to cut and paste commands into our shell, we can't do that with our GUI we have running here. So we've got our JavaScript VNC running here. So what we can do, if we can go back there, is we can run putty on your local machine, and then we can connect to LinuxZoo.net with SSH, and that should pass us on. So that will pass on to your VM that you're running. So we should just be able to log into that Kali VM with the same root in Kali, and we should actually be able to cut and paste things in and out of this window. So especially for the practicals, if you get used to running the GUI in one window and maybe a one SSH window as well, it'd be quite handy for cutting and pasting not only some of the things from the practical, but also some of your answers. You can cut and paste things like MAC address. So I think we, yeah, so if we wanted to look at the MAC address, we can actually now, just by selecting that, it actually copies it. And if we go back to where we wanted our MAC address, oh, I filled it in maybe already, we can actually paste that in. Okay, so similarly we should be able to take this for loop. So I suggest that you actually type this in yourself if you're, we can actually just right click and it should do that for us. So we've got a for loop creating the variable I in this range, and then this is what we're actually going to do for each iteration. So we're going to do, so there's a terminator here for the first part of the for loop. This do is going to do this command, so we're going to send 2 packets into here, and we're going to replace this with the variable. So it's going to start with 1 and then go up to 30, and then this is just a terminator. So your do and your done are a bit like the curly brackets in any other language. Okay, so let's try that. Okay, so that's busily pinging away. So it's our first one's to 1, and then to 2, and we're not getting anything back, and then 3. So that might take a little while. Meanwhile, in our GUI window, this is now monitoring this and then recording it to this file. So while that's running, we'll have a look at the lab. So it's asking us to look at, so it may take a minute. Looks like it may take a little bit longer than that. So it's complete, stop the capture. So stop the capture, which gives us access to the file, which is what I got wrong in the first place. And so it should say that it's started, so it's not finished yet. So use grep and locate all the packets, including an echo reply. So we're going to have to grep that file and look for replies. And we're looking for the sequence number of the last received reply. So whichever replies we find, we're looking for the last one. There we are, so we've finished in that window. So if we stop this window, we should be able to. So yeah, we've got something in our dump file, which is just finished writing there. This is just now. So if we take a guess that reply might be what we're looking for, let's see what we get back. So we do get some lines back. And it was asking for the ID 3971. Let's try that. Last reply sequence number. Maybe we've got the wrong thing. Sequence number 2. Suspect that's not what we're looking for. Okay, I think we might need to cat the file out. So if we cat the file and then pipe that into less so we can look up and down the file. So if we use Control F, we can go forward through the file. Control B goes back a page at a time, and we can actually use the slash to search for something. So if we search for reply, we can use question mark to search backwards. There we go. So that should be the last reply, and actually what we're looking for is, this is the entire packet, so we only grepped out these lines. So actually we're probably looking for the ID of the entire packet, which starts here. So that would be 1022. Let's try that. Excellent. Okay, so that's, yeah, sorry. So there's a pair there. So this is the packet we're actually looking at. That's the last one, so it's sending pairs. So the last one looks like it's 1023, fingers crossed. There we are. So we do sort of know what we're doing after all. Excellent. So now we'll use grep and WC how many echo requests were sent. So we could quit with Q out of that less, and so similar to what we did before, we could grep for requests in that file. That's going to give us all the requests. So how many have we got? Well, we need to pipe that into word count, and I would suggest doing lines. So I'd assume that would be the right answer, which I'll let you check. So there's some other things, grepping some stuff out. We've got tcpdump again, and we've got some of our other filters here. And we're looking for packet lengths. And now we're looking at ARP ping, host sweeping.